So we have an alien spacecraft, and it is rising vertically from the ground at a rate of 70 yards per second. There's a little boy filming from the ground from a distance of 400 yards away. And we want to find the rate of change of the angle of elevation of his camera when the spacecraft is 300 yards off the ground. So I'm going to need a visual on this. So let's draw the ground. Let's say this is our ground. And we will let our spacecraft be here. So he's rising up. There we go. There's my spacecraft. And I'll put the little boy over here. He's here and he has a camera. And he is tracking the spacecraft. Like this. What shape is that?
Triangle.
What kind of triangle?
A right triangle.
It's a right triangle, which is pretty simple, right? Let's see what else we know about this problem.
There's a constant.
There's a constant. What is it?
400 yards in the ground.
From here to here, right?
Yes, ma'am.
Yes, so this is 400. Okay, so I can put that there. Am I allowed to put the 300 here yet? Because that's not remaining constant. You can only put in numbers that are going to remain constant throughout the problem. So if we have a spacecraft rising, the only thing that's going to remain constant is that 400. This angle is going to be changing. This height is going to be changing. And whatever this distance is going to be changing. None of those are constants. But that 400 is going to be constant, right? Because the little boy's camera is not moving. Are we good? Okay. So, let's see here. We are going to make a given, a find, and an equation. And I'm not really sure whether to use sine, cosine, or tangent yet. I just don't know. Typically, angle of elevation problems are tangent, right? Because they don't typically involve the hypotenuse. Like usually we're not interested in this distance. We're interested in the straight line distances. So usually they're tangent, but I'm not sure. So I'm going to fill in the G and the F first. I gave you that it was rising vertically at a rate of 70 yards per second. So is that dy dt or d dt or d theta dt?
It's dy dt.
That's dy dt. And it's increasing, it's rising, so it's positive 70 yards per second. All right, and then we want to find the rate of change of the angle. So I want d theta dt when it is 300 yards off the ground. So when y is what? 300? All right. So that's the nice thing about trig, is that you don't have to have all three of the sides. You only need two of them. And since I'm not interested at all in this distance, we're going to choose a trig function that doesn't use the hypotenuse. So that would be tangent, right, you guys?
Yes.
So tangent of theta would equal y over 400. So let's let that be our equation. Tangent of theta equals y over 400. So what's the derivative of tangent?
Secant squared.
So we have secant squared theta, d theta dt equals, what's the derivative of y over 400? It may help you guys to remember that this is the same thing as y over 400.
So
1 over 400.
1 over 400.
It's 1 over 400 dy dt, right? So it's 1/400 multiplied by dy dt. Are we okay up to here? All right. Here is what I am looking for. So I need to plug something in. I need to find secant squared of theta, and I need to plug in dy dt, which is great because I know dy dt. What is it? 1 over 400 times 70. So all that's missing for me to finish this problem is I need a value to put in for secant squared. Now here's the thing. A lot of people think that to do that, you have to find theta, but you don't. You should never have to find the angle. I don't really care what theta is. I want what secant squared of theta is. And I'll show you how to find that without actually finding the angle. Okay, so come over here and think through the situation. At this moment in time that I'm interested in, this is 300 this is 400, and we still have no idea what theta is, right? But do you understand that trig functions are just ratios of the sides? Y'all understand that, right? So secant squared is just two of these sides stacked on top of each other.
90, 60, 30.
So we don't care about the angle. We don't care about the angle at all. Okay? I want to know what secant squared is at this moment in time. And what is secant? Do you guys remember?
It's opposite cosine.
It is the reciprocal of cosine. And cosine is adjacent over, so secant is the hypotenuse over the adjacent. I need this hypotenuse to find secant. What is it?
500.
How do you know it's 500?
Because 3, 4, 5.
It's a 3, 4, 5 triangle. So that's an easy one. If we didn't know it, we could use the Pythagorean theorem to find it, and that would give us that. So we don't care about the angle. We just need to know what the secant of that angle is. And the secant of that angle is the reciprocal of cosine. So it is 500 over 400. That's what you put right here. That's all you care about.
You couldn't just plug in 1.2.
Sure, you could. Yeah. I'm just taking it one step at a time. So that'll reduce down to 5/4, right?
Yes.
And then we'll square it, and that would give us 25 over 16 multiplied by d theta dt. And that equals, whoa, I have no idea what that equals. 7 over 40? Right? Then you just multiply both sides by 16 over 25, and that'll tell you what the rate of change of your angle is. So we can find the rate of change of an angle without ever even knowing what the angle is. I think that's pretty neat. So what is 7 over 40 times 16 over 25?
14 over 125.
Everybody get that? What is it?
14 over 125.
14 over 120.
May we have your attention, please?
Okay, so we got what? 14 over 125. And here's the thing about the units. For an angle in calculus, units are never degrees, they're always radians. So it's going to be radians per, is it second or minute?
Second.
Seconds, okay. So it's going to be radians per second. Give that to me as a decimal as well. 0.112.
Yes.
So we could do either one. 0.112 radians per second. So the trig functions, they're not as bad as they seem. They're just based off of, SOHCAHTOA and a right triangle situation.